Alright, good day guys. Talking about naming of alkane skeletal structure. It is still the same law you have to follow when you are naming your normal alkane. And how do they function? You see these tricks you guys are seeing, they are bond. Normal bond that bonds CH3 and CH2 together. The single bond. So if you have to look at this now guys, every corner, this is a terminal, this is a terminal, this is a terminal. And at the terminal of alkane, you always have a CH3. You get what I'm saying? So these are terminal, and these are prior to have a primary carbon atom. So since this is a single bond, this is another single bond. They meet at a particular junction here, and if you are being given two bond from CH4, two hydrogen has gone already. Two hydrogen has actually left, so you have ordinary CH2. So I'm having CH3 at the end of this terminal carbon, CH2 at this corner. Another two bond lost again, CH2 here, CH2 here. Now if you look at this now guys, I have 1, 2, 3 bond attaching to here, so I only have one hydrogen, which is ordinary what? CH. With what? With my streak. My CH3 here, and the outer point you have CH3. So talking about how to name them, the first law is that you have to locate the longest chain of the carbon atom. So that one will determine our parent what? Our parent. You just look at the longest one, the one that is longer. Now if I'm to count from here, let's start from this idiot here. If I'm to count, I have 1, 2, 3, 4, 5, 6, right? I also have here 1, 2, 3, 4, 5, 6, which means I'm counting 6. I'm also counting 6, right? Now we usually look at this as an example. Now if you look at this now guys, look at the second rule. The second rule tells us that the number the longest chain, beginning with the end of the chain nearer to the substituent. Now guys, you are to number the longest chain. Now not just numbering only the longest chain. Whenever you have a case like this, you have to go for the longest unbranched chain if they are equal. Now since they are the same thing, the longer unbranched chain is what? Is this. This is branched. So you count from here. You have your point, 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 and point. Are you with me? So this is our substituent. That's make it a substituent. Now if I want to count now, look at the second rule. The second rule tells us that what? You have to number the longest chain. Abi, we know that already. And if we have to look at the longest chain, you have 1, 2, 3, 4, 5, 6, which gives us alkane ends with ANE. Then just add your normal names. Pentane, and the rest like that. So we have this as 6, and this is what? This will give us hexane, right? Hexane, that is our parent chain. Exactly. It is not insane. Now, it says that you are now to look for the chain that is nearer to the substituent. That is where you start your naming from. Now, if I'm to count now, guys, I can't count from here. This one is far. This one is near. This one is closer. So I can say 1 and count my what? My 2, right? Closer. Then my 3, then my 4, and my 5, then my what? My 6. Are you get what I'm saying, guys? The one closer to it, that is the one we have to count. Then the third law, it says that you are now to use rule 2 to designate the location of the substituent. Now guys, where is the location of the substituent? 2. Are you with me? So whenever you want to name this now, it has become a normal naming function, which tells that this is 2 what? Methyl, and the parent chain, which is what? Hexane. Hexane. Let me erase this upper part so that we can what? We can have a good naming. Now this gives us 2 methyl and what, guys? Hexane. 2 methyl hexane. Now let's come to this idiot here now. Let's count first, guys. You have 1, 2, 3, 4, 5, 6, right? Now this is a straight, it's not branch. But if whenever you are to give attribute to the unbranched, is when you look at the branch and the unbranched and they are equal. If the unbranched is greater, you must not count simply because this is a branch now. No. You have to move to the unbranched. And if I want to count this unbranched, I have 1, 2, 3, 4, 5, 6, 7, greater than 6, which tells us that this is the substituent. Are you with me? Now look at now, guys. Look at the rule 4. It says when 2 or more substituents are present, give each substituent. Okay, let's ignore rule 4. Let's name this now, guys. To count from the closer one, right? I can't start from 1, 2, 3, 4, 5 here. It is far. 1, 2, 3. So I have 1, 2, 3, 4, 5, 6. 6, 7. Which means our parent chain is what? Heptane. And this is ordinary 3-methyl. This is the CH3 group. That will be what? 3-methyl heptane. Are you getting what I'm saying? Like maintain, like Olu maintain. So the help is to attain some things. Now that is for the theory. Then the fourth one, now let's count the fourth one. I have 1, 2, 3, 4, 5, 6, right? I also have 1, 2, 3, 4, 5, 6. Now in this case now, I can actually choose any, simply because I actually don't have any choice. They are both in the same level. Now, if you are to look at this now, guys, there's something you have to note. People do misquote the word ranking of substituents. Now you see an alkyl group, you are ranking them based on the first alphabet, not with their stature. So if I'm to have methyl and I have propyl, I will name methyl first before I name propyl. But if I have methyl and I have ethyl, I will name ethyl first before I name methyl. So do not forget that, guys. So it is only this is the first alphabet ranking, not their name or where they are being categorized. Now, coming back to this, we have one substituent here, right? And also I'm to count 1, 2, 3, 4, let's say 5, 6. I will also have another substituent here, right? So I have 1, 2, 3, 4, 5, 6. I'll count from here. 1, 2, 3, 4, 5, and 6, which gives us what? Hexane. Now, if you look at this now, guys, this is one kind of structure. It is a substituent also. Then how do you know? CH3 CH3 and CH2. Then CH3 and CH2 combined together gives us an alkyl group of what? Ethyl. Are you with me? So, and since ethyl starts from E, we will name ethyl first before methyl. Are you with me? So you have this forward, but the number assigned, number destination must not change. As you can see, not because of ethyl is here, I had to move here because I'm counting from a 1 to 3. I'll meet at 3 here, which is far, but 2 is closer. But naming it, you have to give it the normal attributes. 4 ethyl, then 2 methyl, and you have, it was 6. It is 6, Abby. That will be hexane. So you have 4 ethyl, 2 methyl, and what? Hexane. Now let's look at this fifth one. Now guys, let's count. I've talked about the fourth, third, second, first, right? So talk about the laws of that, the law or the rules. Now it says number 5 says that. Okay, let's look at this for one. It says when 2 or more substituents are present, give each substituent a number corresponding to the location on the longest. That means that let's say I have 2 substituents on the same location, I'll give them 2 this one, 2 this one also. Are you getting what I'm saying? So that is for the fourth law. But let's count this first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So I guess this is long. 1, 2, 3, 4, 5, 6. Are you getting what I'm saying? So now it depends on how you want to count this. 1, 2, 3. I will count from 3 because this is for 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. Are you getting what I'm saying? Now guys, if you have to look at the rules tells us that, or told us that, whenever you have them on the same lane, you name them normally like that. Now to look now, I have a methyl in one part, and also I have an ethyl here on the other part, because this is CH3 and CH2. So I'll be having the ethyl first. 3 ethyl and 3 methyl. 3 ethyl, 3 methyl. It is 4, right? Hexane. So 3 ethyl, 3 methyl, then what? Hexane. Do not forget that, guys. So that is for the let's move to the sixth one. Now look here now. It says that the fifth say when 2 substituents are present on the same carbon atom, use the substituent twice. When you have the same substituents on the same carbon atom, use them twice. Now look here now. We've seen about 4 for you wrote this one, right? That's you naming them the same number, but it is different, not the same substituent, different substituents. Now whenever you have the same substituent on the same carbon atom. How do you do that? Before that, let's move on to number 6. Let's see if number 6 is attached to the number 5 rule. Now let's count 1, 2, 3, 4. So counting from here, 1, 2, 3, 4. We have the same counting. So let's just see 1, 2, 3, 4. So we have this and this as our substituents. Are you with me? 1, 2, 3, 4. Now, whenever you have something like this, guys, let me read this number 6 rule. Now, when you have 2 or more substituents that are the same thing, as you can see, now this is methyl, and this is 2-methyl. You have to give them the name, this name. That's if it is 2, you call it di. If it's 3, you call it tri. But you write their name. How do you write their name? Now you have the first closer one is 1, 2, and before 3 abi. So you put 2, 3. Then you write your di. Are you with me? Because it is 2. Then di-methyl. We count it as 1, 2, 3, 4. That will be what? Butane. Are you get what I'm saying? 1, 2, 3, 4. So 2, then 3. How many? It is 2. Di. Then what substituent? Methyl. That will be 2, 3 dimethyl butane. Now look at this 7th one now. Let's count. You have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's just say 1, 2, 3, 4, 5. The longest on branch. 1, 2, 3, 4, 5. Since they both they all give us 5. Now what do we do here, guys? These are all methyl now, right? So you have this substituent. Now moving from here, to move from 1 to here, I have 1, 2, 1, 2 here closer, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So anywhere I move through, it is still the same way. So I have 1, 2, 3, 4, 5. That is pentane. So I have pentane, and having pentane, 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 2, 3, 4. Are you with me? And that is going to be what, guys? Tri-methyl pentane. So 2, 3, 4 trimethyl pentane. Now looking at this now, this was what this was saying the other time. When 2 substances are present on the same carbon, that's for rule 5, which we want to explain here now. So when they are present on the same carbon atom now, you count them normally. Now I have 1, 2, 3, 4, 5, abi. So 1, 2, 3, 4, 5. Because I want to count backward again, still same to 1, 2, 3, 4, 5. So you see I have 2 methyl here on the same carbon. Then 4 also on the same carbon. So this gives me a total of 4 bundle. 4 bundle. Then that will be 2, 2, 4, 4. And this is how many? 4. This will be tetra methyl, then pentane. So 4, 4 tetramethyl, then what? Then pentane. So let's look at this other one. Then number 7 says, when chain of equal length compete for selection as the parent chain, choose the chain with the what? With the greater number of substituents. Now at times you might have the same numbers counting back and forth, but you have to choose the one that has much more substituents. Now let's look at this now. 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Look at what they are talking about. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I have this. Then counting from here. 1, 2, 3, 4, 5, 6, 7. Now why I can't choose this is simply because of the rules I have to obey. The straight on branch rule. Since they are the same number, I have to choose the straight on branch rule. So it depends on what I'm counting. 1, 2, 3, 4, 5, 6, 7. Are you with me? So do not forget that. So this is a substituent. This is a substituent, this is a substituent, this is a substituent. We have 4 substituent there. So how do we start our numbering? 1, 2, 3. You have 1, 2. So we count from here. 1, 2, 3, 4, 5, 6, 7, which is heptane, right? That is heptane. So moving on from here, to count the structure here, you have 1, 2, 3. This is propyl. And I told you guys something that the propyl will be named before the methyl. Don't forget. And now that will be, what number is the propyl? 1, 2, 3, 4. That will be 4. 4 propyl. How you get what I'm saying? Then you have 2 methyl, 3 methyl, and 5 methyl. So you have 2, 3, 5. That will be tri methyl, and this would be what? Heptane. How you get what I'm saying? So 2, 3, and 5 trimethyl heptane. Do not forget that. Now guys, from there, moving on. Now, I tell you guys that the E comes before the O, right? So that is why methyl has to come before what? Methyl. So, oh sorry, I did mistake, sorry. I tell you guys that what, since methyl, you have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So methyl will come before the what? Before the propyl. Do not forget that. So you have, that will be 2, 3, 5 trimethyl. Are you with me? 2, 3, 5 trimethyl. Then you have your 4 propyl. Are you with me? 4 propyl 4 propyl heptane. Yeah, 4 propyl heptane. Now look at this last one now, guys. The last one, which you have here, 1, 2, 3, 4, 5, 6. Okay, this is actually straightforward though. Now the last rule tells us that, I'll explain all the rules already. It says that when branching first occur at an equal distance from either end of the longest chain, choose the word name that gives the lower number at the first point of difference. Now if you look at this now, guys, this is more like you being given the values of 2 different them. If you have to look at this now, these are equal already. But where am I assigning my number from? From 2 here, and not what? Not 3. We all know that already. Second is that if you are being given the same end, make sure that what? You go for the longest on branch chain. Very important. Now, this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's just count this. Where should I start from? Anyway, I start from, I'm saying, okay, 1, 2, 3, 4, 5, and I have 6. Are you with me? So I have 2, 3, and 5. And this is hexane. So that will be 2, 3. These are substituents. So that will be 2, 3, 5. And you have your methyl hexane. So that is how to name a normal alkane with a normal substituent. So you guys should follow up for naming heteroatoms and other organic compounds. My name is Crypto Quanta. Please kindly subscribe. Thank you.